Hi, I am Mohit Kumar Panigrai, a second year BTech Computer Science Engineering student at Lovely Professional University. This series is a summer project where I am teaching Python programming for the ground up, following my university's own INT 108 syllabus, unit by unit. Over this series, we will go from installizing Python and writing your first program all the way through conditional loops, function, and recursion and object oriented programming and file handling, plus every practical lab program from the syllabus itself. Each video has a downloadable slide deck linked in the description so you can follow along, take notes, or revise later without rewatching the whole thing. Alright, let's get started. Hey everyone, welcome back. This is video 2 in our Python series for INT 108, and today we are covering unit 2A. So let's start with conditional statement. If you have watched the first video, you already know how to store data in variable and do basic math on it. Today we teach you our program to actually think a little, to look at a level and decide what to do based on it. Instead of just running the same fixed steps every single time, no matter what. This is genuinely one of my most favorite topic to teach because it's the point where Python stops feeling like a fancy calculator and start feeling like a real living program. By the end of this video, you will be able to write code that reacts differently depending on what's happening, checking someone else before letting them do something, reacting to a random dice roll, and sorting number into categories like grade. That kind of things almost every real program you have ever used in your life. An app, a website, a game is fundamentally just a very long chain of decision like the one we are about to write today. As always, the slide deck for this video is available to download in the description along with all example code we are going to write. You can grab that and follow along on your own machine without having to pause and copy everything down by hand. I would really encourage you to have your own editor open right now and type this example yourself as you go rather than just watching. That's genuinely the difference between remembering this in a week and forgetting it by tomorrow. Let's get started. So, so today what we will cover? Quick look at what I had today. So you know roughly where we are headed. We will start with comparison operator, the tools that asking for simple questions like is this number greater than that one, or are these two things equal. Then we will connect that to a boolean values properly, since that's really what a comparison gives you back. After that we will look at logic operator and or and not, which let us combine more than one question into a single more complex check, like is this person over 18 and do they have an ID. So then comes the main event of the whole lecture, is if, elif and else, which is the actual mechanism Python uses to run different code depending on the situation. We will look at nested condition, which just means putting one if inside another if for handling situation where one decision depends on another. Then we'll bring in the random module to generate random numbers, which pairs really natural with everything else we are covering, and we'll close out with a rundown of the handful of specific mistakes almost every single beginner makes at the exact stage of learning, so that when you hit one yourself, and you will recognize exactly what's happening instead of getting stuck confused for 20 minutes. So basically, I will let you tell an example for if and false. Like if your age is more than 18, then you can vote. A simple vote machine that we can use later. Okay, so that's how a simple machine is created from a simple basic formula like if, elif, else, and using for loop that will later cover. So a quick recap in the last video. Before we move forward into new material, let's do a genuinely quick recap of the video one, just so everyone properly warmed up on the same page, especially if it has been few days since you watched it. We have covered variables, names that point to values, stored memory, created using the equal sign. We covered four code types: whole number called int, decimal, float, text, string, and true false values called boolean. And we covered basic operator things like plus minus for arithmetic and the percentage sign, which gives you back the remainder for division rather than dividing the result itself. Everything we are doing today builds directly on top of that foundation. We are not throwing any of it away. We are just putting it a genuinely new use. And here is the single big idea for this entire video. The one thing I want you to walk away remembering, even if you forget every specific detail, every design of Python. Okay, let's just do a quick revise. Okay, so we'll follow this model. Yeah, it's very nice now. So, first of all, what is programming? Like we discussed in last class, programming is the process of giving instruction to computers so that it can perform tasks, solve problem, and automate work. What is Python? Python is one of the easiest, most beginner-friendly programming language. Its syntax feels close to simple English, which makes it easy to read, write, and understand. Python is widely used in web development, automation, artificial intelligence, and machine learning in data science and software development. Let's have to install it. Already done it in last class. Then there are the types of module. Okay, modules. A module is a file containing code written by somebody else which can be imported used in our programs. Pip is the package manager for Python. You can use pip to install external modules on your system. There are two types of module in Python: built-in module and external module. So example of built-in modules are OS and random. Example of external modules are TensorFlow and Flask. Okay. So you can use directly using the in terminal using the REPL, which REPL stand for read, evaluate, print, and loop. Okay, so remember that. Now we had already discussed comment, and this is the practice set you can do. Try do it on yourself. Then the variable we discussed in last class. What are the data types, rules for choosing identifier? Remember, when you are discussing about identifier, a variable name can contain alphabet, digit, and underscores. Nothing else than this. A variable can only start with alphabet and underscore. If we are starting with the digit, it is not recognized as a identifier. No white space is allowed to used inside a variable name. Okay. So these are the some points. Remember, operators we had already discussed. Now the type function already discussed. What type, like if this a is equal to 31, its type is called class int string, that we already discussed all. So today we are going to start with strings we had already discussed last class. Also, let's start with this. Okay, string. I guess we haven't remember that. Okay, so basically string is when you write a name Harry. Okay, then we just quote it. It's called string. Then inside that name, see, always remember the index start from 0. Okay, so first is 0, 1, 2, 3, 4, and if we reverse it like -1, -2, -3, -4, the last word is always -1, so remember that. Now for a string to start, you first write the name, like the variable that containing Harry. Okay, so that's name. Then we close square bracket. There we first write the start, then in end. And if we want to do like first we do the index 1, then directly move to index 2 ignoring the 1, then we can write here another double stop and write the step, that is 2, like see here. See, Here he has written word 162. Okay, so here 2 is the called this step. Basically this is the first index where you are starting, this is the last index, and this is the step. Okay, so that's now string function, we had already done it. Now let's move on to list tuple, and this is okay. So let me come back to our own slide. A quick recap, we had already done. So modulus operator revisited. Okay, so let's revisit this. Let's start with something we already technically know from last time, the modulus operator. The percentage sign in last video that I described it fairly abstractly as the remainder operator, and honestly on its own that probably didn't feel very useful yet. Today let's actually put it to work for something genuinely practical. Okay, so let's put it. So try writing this down code. Okay, so what is happening here is, so number is equal to 7, print number, oh sorry, okay, print number divided by 2, so that will give you an 1 which is odd. I mean it will provide you the remainder, and if it is divisible then it's even. It's basic idea. So let me give you an homework. Okay, just try and then print check whether it is odd or even. Okay, if it is odd then print odd, and it is even then print even. Okay, just try that. So here is the actual trick. The reason we are spending time on this, or any number where number divided by 2 is equal to 0 is an even number. Any number where it doesn't equal 0, which for dividing by 2 specifically means it equals 1, is an odd number. This is generally the standard universal recognized way that Python programmers check whether a number is even or odd in basically every code base you will ever look at. And it's not just useful today. This exact same trick is going to come up again constantly once we get into loops in the very next video, and where we'll use it to do things like print only the even number in the range, alternate behavior, and other times throw a loop. You can also use modulus with number other than 2, by the way. Number divided by 3, which tells you whether something is divisible by 3 and its building block. We'll come back to directly in the practical lab videos when we check things like perfect number, Armstrong number from our syllabus. One thing worth trying yourself right now just to build real confidence with this before we move on. What's happened with a negative number like -7 divided by 2? Go ahead and try it in your own editor. Python still gives you a sensible, usable answer. It follows a very consistent, predictable rule under the hood, but it's worth actually seeing it with your own eyes rather than just taking my word for it. Since a few other languages handle negative remainder differently, and it's a small trap if you ever move between languages later in a career. Let's also make sure the actual pattern is completely clear with a couple of more quick examples before we move on. Since it's genuinely worth being fast and confident with this, is 10 even or odd? 10 divided by 2 is 0, so it's even. Is 15 even or odd? Let us show the code. Okay, here, whatever, if 15 divided by 2 is 1, so it's odd. Is 0 even or odd? 0 divided by 2 is 0, so a little contradictory for some people. The first time they think about it, 0 counts as even. These are the exact kinds of quick check you will be running constantly once we reach loop next video, where you often want to do things only even on even iteration or only on odd ones. And this model trick is precisely how that gets done. Now let's move on to comparison operators. Now let's properly and formally meet the comparison operator. These are actually tools we use to ask yes or no question about our data. They are the real foundation for everything else in today's lecture. Okay, let me show you in the code. Comparison. Okay, so basically age is equal to 20. So here age is a variable, it stored the value of 20, which is the int. Okay, so now here see, print as equal to 18. So basically that's a false. Okay, let me highlight all this. Wait a second. Okay, now see, now you are printing it, see that it's coming false. So it's saying that as here as value is 20, so it is not equal to 18. So that means when you is called double equal to, checks whether two things are equal to each other. Notice carefully that it's two equal signs in a row, not one. And this single detail trips up literally everyone at some point when they are starting out, myself included, many years ago. So let's talk about it directly and clearly right now, rather than letting you discover it the confusing way. A single equal to is specifically for assignment. It's for storing values inside a variable the way we wrote as is equal to 20 just now. A double equal to is for completely different job. Asking the question, are these two things equal to each other? So this is basically asking if as is equal to 18. Okay, so it's not specific that as is equal to 18. Got it? So it doesn't change or store anything at all. It purely checks and hands you back either true or false as the answer. If you accidentally write something like if age is equal to 18 with a single equal sign, the good news is Python is won't even let the program run at all. It stops you immediately with a syntax error before anything executes, which is honestly a small mercy on Python's part, because in some other language that exact same mistake falls silently into a much more confusing, harder to spot way, sometimes running a successful but doing something you never intended. So now let's move on to the next part. See, now coming to as not is equal to 1 8 10. So it is not equal to, basically the opposite question from double equal to. Smaller than and greater than are working exactly the way they did back in math class, and smaller than is equal to and greater than is equal to are greater than or equal to. Okay, so for when you want to include the boundary value itself as a match, not just value strictly beyond it, it's worth pausing on the last distinction for a second between smaller than and smaller than equal to, because it's a kind of small detail that quietly causes real works later if you are not deliberately about it. If a syllabus rule says student need 40 or more marks to pass, that marks equal to more than 40, since exactly 40 should count as a pass. If you accidentally wrote marks greater than only 40, then student with exactly 40 marks could incorrectly be marked as failing, even though the rule says they should pass. There is no way for Python to catch this kind of mistake for you. Both versions are perfectly valid, error-free code. They just mean two subtitle different things. So whenever you are translating a real-world rule into a condition, it's worth reading the rule back to yourself carefully and asking, does the boundary value itself count or not, before deciding between the strict uh, and the or equal to version of the operator. See, now I will write this. Oh, we'll first check this. What's the value are we providing? Okay, I will comment it out. Now let's run it. See, here as is not equal to 18, whose answer is true. As is greater than 18, answer is true. Okay, so that's what I'm talking about. With as set to 20 in this example, is as equal to 18? No. 20 and 18 are different numbers, so that evaluates to false. Is as not equal to 18? Yes. Since they're genuinely different, that's true. Is as greater than or equal to 18? Yes. 20 is comfortably above 18. So that's also to try changing the as variable to a few different values yourself right now. Try 18 exactly, or try 10, try 100, and predict what each line will print before you actually run it. That kind of mental prediction and checking yourself against the real output is generally one of the fastest ways to build real intuition here. It's worth knowing that these comparison operators aren't limited to just number. You can compare strings to apple is equal to apple gives you true. Apple is equal to capital A apple. This will be false because it's Python is case sensitive. Okay, we are already discussed in first lecture that if here A is capital, okay, so it will give you false, but if smaller A it gives you true. So check this, try example yourself and do it. Okay, let's take a water break for a few minutes. Okay, let's get back to the topic. So now let's move on. We are clear about this, right? Comparison operator. Okay, now let's move on to Boolean expression. So every comparison we just wrote is an expression that evaluates to a single Boolean value, true or false. Nothing more, nothing less. That result can be stored in a variable, printed, or most usefully handed straight to an if statement. Like, let's see the example here. Okay, so is adult is adult is equal to age greater than 18. So print is result true, because here we had already give the as value as 20. Okay, so that's why it is true. But if you take an input from user and check it, then it will the answer will be differ. Okay, so that's how Python works. And when you check the type of the is adult, it gives you a boolean value. Okay, this might feels like a very small, almost obvious detail sitting here on its own right, but honestly, it's actually the entire conceptual foundation for everything else we are covering in this whole video. An if statement, which we are about to look at properly in just a couple of slides, is generally nothing more than something that looks at a boolean value exactly like this one and decide what code to run based on whether that value is true or false. Once that clicks properly, the rest of today's lecture is really just layering more tools on top of this one core idea. Okay, let's think about how naturally you already do this in everyday life, honestly, without ever calling it a boolean logic. Is it raining? Is a yes or no question. Do I have an umbrella? Is another yes or no question. And what you actually do next, grab the umbrella and don't depend entirely on the answers of to those two simple questions. That's generally all a computer programming is doing too. Just one of these small yes or no checks chained together and a lot more precision about exactly how they combine, which is exactly what we are building toward in the rest of this lecture. So, okay, let's just run the code, okay, and check whether it's a boolean or not. See here, you are running it. It's true, and class is boolean. Bool. Actually, bool is a short form for boolean. Basic example. Okay. Now let's move on to logic operator. Sometimes just one single question isn't enough on its own. We need to combine two or more separate conditions together into one bigger check. That's exactly what and, or, and not are for. So let's reference to the table. And true only if both sides are true, or true if at least one side is true. So it's basically saying that in and we need both the case to be true. Okay, so if one is false, another is true, then it will give you false. But in or, only one need to be true. If one is false, another is true, then it will give you true. Okay, so and not flips the true to false and false to true. So not basically flips the example. Let's try and code here. Check. As is equal to 20, has id is equal to true. So print as is equal greater than 18 and has id. Okay. So here both are true. Therefore it will print what? True. But if, let me tell you, if we write less than 18, okay, let's highlight all this. Now if you print, see it's giving error. Wait a minute, what the heck. Age is not defined. Why it's not running, bro? Okay, here, see, it's false. And sometimes there is a glitch. Okay, so basically I am doing it offline, and that's why. Here, see, it's giving false. Okay, so now let's undo all this. Okay, now let's check here. Print as smaller than 18 or has id. So both are true. It need at least one is true. Okay, the answer will be true, of course, and not has id. See here for the third case, look at the third print. Okay, see here this third case, it's giving me false because has id is real value is true, so it's just reversing it and it's saying false. That's also you need to remember. Now if statement. Okay, so a genuinely simple way to keep straight in your head while you are still building habit, thinking up and as strict. Everything involved has to check out for the whole thing to pass. Think up or as relaxed. Just one thing checking out anywhere is already enough to pass, and not is just a flip switch. Nothing more. Here's a real world way to anchor all of three of these in firmly in our head. Since the words themselves are already familiar from everyday English, which honestly helps a lot more. Getting into a nightclub usually needs 18 or older and a valid ID. Both condition, no exception, and that's yours. And getting a discount at a shop might be student or senior citizen. Either one is already enough. That's a roar. And the shop is not open. It's just not direct opposite of the shop is open. Flip the truth. That's your not. You can also combine all three together in one line, like as greater than is equal to 18 and has ID and not is banned. And Python evaluates its rap left to right. Okay, so basically It's saying that Python always start from left to right. Okay, it goes in this way, not reverse. So remember that also. I mean, it can sometime ask an interview that where Python starts. So basically, Python start from one position to last. Okay, from index 0 to last. So let's also make sure the four possible combination with and or are completely clear. Since this is OR doing fasted with and true gives true, true and false gives false, false and true gives false, false and false gives false. In other word, the only way to get true is out is both sides are true, and with OR it basically flips. True or true gives true, true and false gives true, false and true gives true, and only false and false gives false. The only way to get a false out as if both sides are false. If that's a lot to hold in your hand at once, don't worry about memorizing the table itself. Just remember the one line summarize and needs everything to check out, or only needs one things to check out, and you will be able to reason it correctly every time you memorize anything. So now let's move on to the if statement. Now actually the star of this entire lecture, the if statement, which is the real mechanism a Python uses to make genuine decision and behave differently depending on the situation. So when we write as is equal to 20, wait, as is equal to 20, if as greater than is equal to 18, print you can vote. So if it you first check as is greater than 18, if it is greater than 18 then you can print, yeah, you can vote. If it's not, then it will not print. Okay, that will come to later, it's in the if else part. So the line if as greater than asks you a yes no question. If the answer is true, the Python runs the indented block underneath. If it's false, that whole work simply skipped. Python uses indentation, usually 4 space, to mark its line belong that if block. If it this isn't a style choice, it's a part of the language grammar. So basically what happens is Python follows the indentation basically. So what is indentation? Indentation is the 4 space that comes after this mark. Okay, when you click enter it will show you 4 space. Okay, if it doesn't show, you can write on your own 4 steps, because if you don't do that then it will show an indentation error, because Python strictly for a grammar rule for its own. Two small but genuinely important details worth calling out clearly here, because they are both easy to miss the first few times. First, notice the colon, okay, sitting right at the very end of the if line. If that column is required, it's not optional punctuation, and Python simply will not run the program without it, giving you a syntax error instead. Second, notice the indentation on the line directly below it. This is not just a formatting neatly or a matter of personal style. In Python specifically, indentation is how the language itself actually knows which lines belong, that is the blocks. Let me show you directly. Okay, sure. If statement, see, we are just, let me remove it now. If we run this, so see there is an error showing. Okay, but after putting it and coming back, see there is a 4 space indentation. This is called the 4 space. So basically, see, let me click on it. Okay, see what it see, 1 2 3 4. That's a 4 style. Okay, 4 time. So most good editor, including VS Code, will automatically ident the next line for you the moment you step that colon, hit enter. So in practice, this becomes second nature pretty quickly, but it's not genuinely worth understanding clearly why it's matter. Rather than just blindly trusting your editor to handle it without knowing what's actually going on underneath. You also not limited to a single line inside an if block, by the way. You can put as many lines as you need underneath, as long they're all entered in same level. Try adding second line underneath. See, we can add as many line as we can. Okay, like that time let we add it once more time. We are copying it and directly moving next line and pasting it. It will run all the, see, it's running welcome to voting 2 times. Okay, so you can add as many line as you can. So that's what understand. So let me show you here. Where is the set list will cover in the next lectures. So just see. So conditional expression. Sometimes we need to play PUBG on a phone if the day is Sunday. Sometimes we order ice online if it's sunny. Sometimes we go hiking if our parent allows. All these decisions which depend on condition being met. If else elif statement are multi-way decision taken by our program due to certain condition in our code. If condition, print yes. If elif condition to print no, else. So now let's show you what elif else means. So if else, right now as written, our Latin program actually does something when the condition happens to be true. But what should happen when it's false instead? Right now nothing does, which usually isn't you actually want. That's exactly what else is for. So basically what happen is when the if statement gives you false, what happen? If we had and write any else statement or elif statement, there will be nothing done. Okay, so we write the else statement. So basically for every if there will be else, but elif is not necessary now. Elif is for if we are checking more than one two condition. Okay, so else print not elif. If it's false it will print this. If it is true, print this. See, else doesn't take any condition, it says when it is false. Okay, let me show you the code. See, if has a condition but elif else doesn't has a condition. It will only run when the first if statement is false. Okay, so here if as greater than equal to 18 turns out to be true, we print you can vote. But if it turns out to be false instead, Python jumps straight past the first block entirely and runs the else block instead, printing not old enough yet. Exactly one of these blocks, two block run every single time the program execute. Never both of them together and never either of them at all. That's really the whole purpose that else serves, and it acts as a catch for all absolutely everything that if condition didn't already match. So your program always has some defined path forward no matter what values comes in. Let's look at one more quick example to reinforce the pattern with a different kind of check. This time temperature. Imagine temperature is equal to 38. If temperature greater than 38, 37, print you might have a fever. Else temperature looks normal. So we can also take input from user. Okay, so basically we use input for that. Then we use the input command is basically used for to take input. See here, so we can use that also. Now let's move on to the next part, if else elif. Okay, we'll come to that, don't worry. Now for if elif else, real world decisions are often more than just a simple to or through. That's precisely where elif or else is. Okay, so what exactly happened here together? Step by step, this same careful Python itself actually processes it. Marks it to set. Mark is set to 72. Python start at the very top and check the first condition. Is mark greater than or equal to 90? No. 72 is clearly less than 90. So that check comes back false and Python moves on to the next one. Is mark greater than or equal to 72? Still no. 72 is also less than 75. That's false too, and Python moves on again to the next check in line. Is marks greater than or equal to 60? Yes. This time it's finally come back true. So Python runs this particular block, print out grade C to the screen, and it stops entirely, completely skipping every check that comes after it. It doesn't even bother looking at the final else at the bottom because it already found its match. That's last point genuinely matter a lot. So let's sit with it for a second. Python check these conditions strictly in the order you wrote them from top to bottom, and they stop the very first moment it finds one that's true. Because of that behavior, the actual order you write your condition matter as a great deal. If you ever had written the greater than or equal to 60 check first ahead of 90 and 75 checks, that then a mark 95 could get incorrectly caught by that first overly bought 60 check, and it could never even reach the proper A grade check further down. Since Python already stopped at a first match as a general rule of thumb or remembering, when you are working with ranges like this, order your condition from most specific down to least specific, generally from highest value to down to the lowest. Okay, so what happen if you move this grades? But let me open the editor for you. What I'm talking about is, if we move this, if we interchange this, okay, let make it grade C and make this A and make this score 60. Okay, and this is 90. So now basically 72 belongs to this grade, it's belong to grade C, right? Let's change this to 92, it's belong to grade A. But see what happen when you run this, it will give you grade C, which is incorrect. Okay, so that's why you need to arrange it as per first, as per your priority. Okay, so first let now see 90, and here we change this to A, and here change to C. Now let's run it. See, it belong to grade A. So basically this is all a case of priorities. So, and remember that if else only run when it get a statement which is true, and if nothing is true then the else case will run. So that's how you need to remember. See here, if condition is true, print yes. If condition 2 is true, print yes, otherwise maybe. Okay, so here so that's how this work. Elif, because elif in Python means an if statement can be chained together with a lot of this elif statement followed by an else statement. Okay, so there can be an unlimited elif. Okay, but in the last there will be an else case. Without else we can't run this. Okay, so remember that there can be any number of elif statement. Last else is executed only if all condition inside elif fails. Okay, so remember that. Now try this practice statement. We are pausing it here. Let's take a 10-minute break and we'll come back later. Now practice this set of question. Okay, start with this to this. I've given you 10 minutes, just try this and then I will be coming back. Okay, so let's take a break. There are a lot more slides to go. Wait, let me show this. Okay, there are 7 slides left,
models are built the way they are. Similarly, Python was created to solve problems that older programming languages had. Understanding those problems helps you understand Python much better. Objective 4, why Python is popular. Popularity doesn't happen by accident. Millions of developers around the world use Python. Thousands of companies depend on it every single day. We'll understand the actual reasons behind this popularity, not opinions. Real reasons, like readability, community support, huge libraries, cross-platform compatibility, and rapid development. Objective 5, real applications. This is one of my favorite parts. Many beginners ask, where is Python actually used? We'll answer that in detail. You'll discover that Python powers things you use almost every day. We'll explore examples from industries such as artificial intelligence, web development, automation, data science, healthcare, finance, cybersecurity, scientific research. You'll begin to notice Python everywhere. Objective 6, career opportunities. Finally, let's talk about careers. Learning Python opens doors to many exciting fields. For example, software developer, data analyst, data scientist, machine learning engineer, artificial intelligence engineer, automation engineer, back-end developer, cybersecurity professional, cloud engineer, research scientist. The best part? You don't have to decide today. Python is flexible enough to let you explore different paths before choosing one. Before moving to the next slide, I'd like to ask all of you a question. Why are you learning Python? Is it because you want a job, you want to build AI applications, you're interested in web development, you want to automate repetitive work, or are you simply curious about programming? Take a moment to think about your answer, because throughout this course, I want you to connect every concept you learn with your personal goal. That will make learning much more meaningful. And with that, we've completed the introduction and the roadmap for our course. Now it's time to answer one of the most important questions of the entire journey. What exactly is programming? We'll explore that in the next part of the narration. SLIDE4, WHATIS programming. Now that we have understood what this course is about and what we're going to learn, it's time to answer one of the most important questions of today's lecture. What exactly is programming? Many people think programming means writing complicated code filled with strange symbols. Some imagine hackers sitting in dark rooms typing extremely fast on black screens. Movies have created this image, but in reality, programming is much simpler than that. Programming is simply the process of giving instructions to a computer to perform a specific task. That's all programming is. Think about your everyday life. Every morning, you probably follow a routine. You wake up, brush your teeth, take a bath, eat breakfast, get ready, go to college or work. Notice something? These actions happen in a particular order. Imagine if you tried to wear your shoes before putting on your socks. Or imagine trying to eat breakfast before preparing it. The order matters. Programming works exactly the same way. Computers don't think like humans. They don't guess. They don't assume. They don't understand feelings. They simply follow instructions. and they follow them exactly in the order we write them. Let's imagine a simple example. Suppose you want a robot to make a sandwich. You cannot simply say, "Make me a sandwich," because the robot doesn't know what a sandwich is. Instead, you'll have to explain every single step. Step 1. Take 2 slices of bread. Step 2. Open the butter. Step 3. Spread butter on 1 slice. Step 4. Add vegetables. Step 5. Place another slice on top. Step 6. Cut it into 2 pieces. Only then can the robot complete the task. Programming is exactly this process. Instead of giving instructions to a human, we give instructions to a computer. Now, here's something interesting. Imagine you accidentally forgot one step. You forgot to tell the robot to put the second slice of bread. What will happen? The robot won't realize something is missing. It won't say, "I think you forgot the bread." It will simply follow the instructions exactly as written. Computers behave in the same way. They never assume. This is why programmers must be extremely clear while writing instructions. Now let's relate this to real-world software. Think about Instagram. When you upload a photo, the app automatically compresses the image, stores it on a server, shows it to your followers, sends notifications, updates your profile. All of these are instructions written by programmers. Similarly, whenever you search something on Google, thousands of instructions run behind the scenes in less than a second. Programming is responsible for all of that. Without programming, there would be no apps, no websites, no online games, no social media, no AI assistants, no online banking, nothing. Programming is the invisible force that powers the digital world. Now let me ask you something. If I asked you to explain programming to your friend after today's class, how would you explain it? You could simply say, "Programming is the process of writing step-by-step instructions that tell a computer exactly what to do." That's probably the simplest and most accurate definition. Keep this definition in your mind because we'll build everything else upon it. Now that we know what programming is, the next question naturally becomes, why do we need programming languages? Let's find out. Now here's an interesting question. If computers only follow instructions, why can't we simply talk to them in English? For example, why can't I open my laptop and write, "Please open YouTube," or "Calculate my marks"? The answer is simple, because computers don't understand human languages. Humans communicate using languages like English, Hindi, Punjabi, French, or Spanish. Computers communicate using only one language, machine language. Machine language consists only of 2 numbers, 0 and 1. That's it. Every image you see, every song you hear, every video you watch, every game you play, everything inside a computer is ultimately stored as combinations of 0s and 1s. Imagine writing a simple calculator using only zeros and ones. It would be almost impossible for humans. That's why programming languages were invented. Programming languages act as translators. They allow humans to write instructions in an easier language. Then the language converts those instructions into machine language that computers understand. Think of Google Translate. Suppose two people are talking. One speaks English. The other speaks Japanese. Neither understands the other's language. Google Translate acts as the bridge. Programming languages perform a very similar job. They stand between humans and computers. Humans write code, programming languages translate it, computers execute it. Let's understand this using Python. Imagine I write, print hello world. This looks very simple. Anyone can almost understand what it's doing, even if you've never programmed before. But inside the computer, Python converts this into machine-level instructions. The processor understands those instructions. Finally, the output appears on your screen. Notice how much easier that is than writing. Binary. Now imagine writing Instagram entirely using only 0s and 1s. It would take forever. Programming languages save us enormous amounts of time. Another important point, there isn't just one programming language. There are hundreds. Each one was created for different purposes. Some languages are better for websites. Some are better for mobile apps. Some are used in embedded systems. Some are used in scientific research. Some are used in artificial intelligence. Python is one of the most versatile among them. We'll understand why in the upcoming slides. Now here's a question for you. Imagine programming languages never existed. Would software development be easy? Absolutely not. Technology would develop much more slowly. Programming languages made software development accessible to millions of developers across the world. So remember this simple flow. Human write-o programming language, write-o machine language, write-o. Programming languages are the bridge connecting us to computers, and Python happens to be one of the easiest bridges to cross. Now let's meet the language that we'll be learning throughout this course, Python. SLIDE 6, Introduction to Python. Finally, we've reached the star of this entire course, Python. So, what exactly is Python? Python is a high-level interpreted general-purpose programming language. I know that definition sounds a little technical. Let's break it down. First, Python is high-level. This simply means it is easy for humans to read and write. Look at these two examples. One is written in a low-level language. Another is written in Python. Even if you've never coded before, you'll probably understand the Python version much more easily. That's why beginners love Python. Second, Python is interpreted. This means Python executes your code line by line. You don't need to convert your entire program into machine code before running it. We'll understand interpreters and compilers in much greater detail later in the course. For now, just remember that Python allows you to quickly write code and immediately test it. This makes learning much easier. Third, Python is general purpose. This means it isn't limited to just one type of application. You can build websites, artificial intelligence, games, automation tools, desktop software, scientific applications, machine learning models, cybersecurity tools, even robots, one language, endless possibilities. Now, here's another interesting fact. Python was created by Guido van Rossum in the late 1980s. His goal wasn't to create the fastest programming language. Instead, he wanted to create a language that was simple, readable, easy to learn, easy to maintain, and enjoyable to use. Today, millions of developers around the world use Python every single day. Some of the biggest companies use Python in their products: Google, Netflix, Spotify, Instagram, Dropbox, NASA, and many more. That's a pretty impressive list. Now let me ask you something. Why do you think companies continue using Python? Because it saves developers time. Clean code means fewer mistakes, faster development, easier teamwork, lower maintenance costs. That is why Python has become one of the world's most loved programming languages. As beginners, you're starting with one of the best choices available. Over the next few lectures, we'll gradually learn how to write Python programs ourselves. By the end of this course, you'll be able to build your own projects from scratch. This is just the beginning of your Python journey. In the next slide, we'll discover the fascinating story behind Python's creation and why it became one of the most popular programming languages in history. SLIDE7W80 created Python. Now that we've learned what Python is, let's answer another interesting question. Who actually created Python? Every great invention has an inventor, just as Thomas Edison is associated with the electric bulb, the Wright brothers with the airplane, Steve Jobs with the iPhone. Python also has a creator. His name is Guido van Rossum. I know the name may sound unfamiliar right now, but by the end of your Python journey, you'll remember it very well. Let's learn a little about him. Guido van Rossum is a Dutch computer programmer. He was born in the Netherlands and had a deep interest in mathematics and computer science from an early age. During the late 1980s, Guido was working on another programming language called ABC. ABC was created to make programming easier than languages available at that time. It had many good ideas, but it also had limitations. While working with ABC, Guido noticed something important. Programming languages at that time were becoming powerful, but they weren't becoming easier. Many languages expected programmers to remember complicated syntax, too many symbols, too many rules, too much unnecessary complexity. Imagine learning to drive a car where every button had a different hidden function. Would learning be enjoyable? Probably not. That's exactly how many programming languages felt. Guido wanted something different. He wanted a language that people could actually enjoy using. He wanted code that almost looked like plain English. He believed programming should focus on solving problems, not fighting with syntax. So during the Christmas holidays of 1989, he started working on a new programming language as a personal project. At that time, he probably never imagined that his small project would eventually become one of the world's most popular programming languages. His philosophy was simple. He wanted a language that was easy to read, easy to write, easy to learn, easy to maintain. Those 4 ideas became the foundation of Python. And surprisingly, even after more than 3 decades, Python still follows those same principles. That's one of the biggest reasons it has remained so popular. Now here's an interesting thought. Imagine if Guido had decided, I'm too busy. I'll do it next year. I'm not good enough. Python might never have existed. Sometimes one small project can change the entire technology industry, and Python is a perfect example of that. Today, millions of developers, thousands of universities, and some of the biggest companies on Earth use the language Guido started as a holiday project. That's truly inspiring. It reminds us that great innovations often begin with one person trying to solve a simple problem. Now, one question remains. Why is this language called Python? Did it have something to do with snakes? Let's find out. SLIDEAWHYICE called Python. Whenever I ask beginners, what comes to your mind when you hear the word Python? Almost everyone gives the same answer, a snake. And honestly, that's exactly what I thought the first time I heard about Python. But here's the surprising truth. Python has absolutely nothing to do with snakes. The name actually comes from a British comedy television show called Monty Python's Flying Circus. Guido van Rossum was a big fan of this comedy series. While creating his programming language, he wanted a name that sounded short, simple, unique, and memorable. He didn't want a long technical name. He wanted something people would remember easily. That's why he chose Python. Imagine if the language had been called something like Advanced General Purpose High-Level Object-Oriented Programming Language. Would anyone enjoy saying that? Probably not. Simple names are easier to remember. That's why companies often choose short names. Apple, Google, Tesla, Spotify. Python follows the same idea. Now here's something funny. Even though the language has nothing to do with snakes, the snake has become an unofficial mascot. You'll often see snake logos, snake-themed stickers, snake plush toys, and snake illustrations in Python communities. So yes, the snake became famous because of the language, not the other way around. Another interesting point, choosing a good name is actually important in programming. Not just for programming languages, but also for variables, functions, and projects. Suppose you're creating a variable to store a student's age. Which name is better? Student underscore age or X123. Obviously, student age, because anyone reading the code immediately understands its purpose. Python follows this same philosophy: readable names, readable code, readable programs. This focus on readability is one of the biggest reasons beginners fall in love with Python. Now that we know where the name came from, let's understand why Python became one of the fastest growing programming languages in history. Now we've reached one of the most important questions of today's lecture. If there are hundreds of programming languages, why did Python become one of the world's most popular ones? Popularity never happens by accident. There are always reasons behind it. Let's understand those reasons one by one. Reason 1, easy to learn. This is probably Python's biggest advantage. Look at this simple Python code. Print. Hello world. Even someone who has never programmed before can almost understand what it does. Now compare that with some older programming languages. They often require extra symbols, brackets, semicolons, complex syntax, and many additional rules. Python removes much of that complexity. This allows beginners to focus on learning programming instead of memorizing punctuation. Reason 2, readable code programming isn't just about writing code. It's also about reading code. Imagine working in a company. Today you write a program. 6 months later, another developer needs to modify it. If your code looks confusing, they'll struggle. Readable code saves enormous amounts of time. Python encourages programmers to write code that looks clean and organized. That's why companies appreciate Python. Reason 3, huge community. Suppose you're learning Python and suddenly you get an error. You search Google. Chances are, thousands of people have already faced the same problem. Someone has already explained the solution. That's the advantage of having a huge community. Millions of developers contribute tutorials, videos, articles, books, forums, GitHub projects, and open source libraries. As beginners, this community becomes one of your biggest teachers. Reason 4, massive library ecosystem. Think of programming like cooking. Suppose you're making a pizza. Would you grow wheat, make flour, prepare cheese, grow tomatoes every single time? Of course not. You use ready-made ingredients. Python libraries work exactly the same way. Instead of writing everything from scratch, you can use pre-built tools. Need artificial intelligence? There's a library. Need data science? There's a library. Need web development? There's a library. Need automation? There's a library. Need image processing? There's a library. Thousands of libraries already exist. This saves developers thousands of hours. Reason 5, cross-platform. Imagine writing a program on Windows, then opening the same program on Linux or Mac. Python works almost identically across all these operating systems. Developers don't have to rewrite everything. This makes software development much easier. Reason 6, used everywhere. Python isn't limited to one industry. It's used in *artificial intelligence, *machine learning, *data science, *robotics, *cybersecurity, *finance, *healthcare, *education, *automation, *web development, *scientific research. When one language works across so many industries, learning it becomes a very smart investment. Reason 7, industry demand. Companies around the world actively hire Python developers. Startups use Python. Large corporations use Python. Universities teach Python. Research labs use Python. Government organizations use Python. This creates a positive cycle. More companies use Python. More students learn Python. More developers build Python libraries, which attracts even more companies. That's one of the reasons Python has remained among the world's most popular programming languages for years. So, if someone asks you, why should I learn Python? You now have several solid answers. Because it's easy to learn, easy to read, backed by a huge community, supported by thousands of libraries, cross-platform, used across countless industries, highly demanded in the job market. And remember something important. Learning Python isn't just about learning another programming language. It's about learning a skill that can open doors to careers in software development, AI, automation, data science, cybersecurity, and much more. Now that we understand why Python became so popular, our next step is even more exciting. We're going to explore where Python is actually used in the real world. From social media platforms and streaming services to artificial intelligence, space research, finance, healthcare, and beyond. That is exactly what we'll cover in the next slides. SLIDE 10, WHEREIS Python USED. Now that we've understood why Python became so popular, let's answer another exciting question. Where is Python actually used? Many beginners think Python is only used by software engineers, but that's far from the truth. Python has become one of the most versatile programming languages ever created. It is used in almost every major technology industry. Let's explore some of them. 1. Web development. Have you ever wondered what happens after you log into Instagram? How does it remember your account? How does it store your posts? How does it know which photos belong to you? All these operations happen on the back end of the application. Python is one of the most popular languages used for back-end development. Frameworks like Django and Flask allow developers to build secure, fast, and scalable web applications. Some of the world's biggest websites use Python behind the scenes. 2. Artificial intelligence. Artificial intelligence is one of the fastest growing technologies today. When ChatGPT answers your questions, when Google Translate converts one language into another, when your phone recognizes your face, Python is often involved. Why? Because Python has powerful AI libraries that make development much easier. Instead of creating everything from scratch, developers can focus on solving real problems. 3. Data science. Every day, companies generate enormous amounts of data. Shopping data, medical records, weather information, sports statistics, financial transactions. But raw data alone isn't useful. It must be analyzed. Python helps data scientists clean data, visualize data, and discover meaningful patterns. Imagine a company wanting to know which product sells the most. Python can analyze millions of sales records within seconds. 4. Automation. Think about repetitive work. Suppose you have 5,000 files that need to be renamed. Would you rename each one manually? Probably not. Python can do it automatically. Need to send hundreds of emails? Python can automate it. Need to organize files into folders? Python can automate that too. Automation saves companies thousands of hours every year. 5. Scientific research. Scientists also use Python. Whether they're studying climate change, DNA sequences, space exploration, or physics simulations, Python helps process massive amounts of information quickly. Even organizations like NASA have used Python in various research and engineering tasks. 6. Cybersecurity. Cybersecurity professionals use Python to create security tools, analyze networks, detect vulnerabilities, and automate security testing. Python makes many security-related tasks much faster. 7. Finance. Banks process millions of transactions every day. Stock markets generate huge amounts of information every second. Python helps financial institutions analyze risks, predict trends, and automate calculations. 8. Healthcare. Hospitals generate large amounts of patient data. Python assists researchers in medical imaging, disease prediction, drug research, and healthcare analytics. Technology is improving healthcare because programming makes data easier to understand. Now think about this for a moment. One single programming language used in hospitals, banks, space research, AI, education, and websites. That's why Python is considered one of the most valuable programming skills today. Learning Python doesn't lock you into one career. Instead, it opens many different paths. And that's exactly why so many students choose Python as their first programming language. SLIDE 11. Companies THATUSE Python. Let's make everything even more real. You might be wondering, okay, Python sounds impressive, but do big companies actually use it? The answer is absolutely. Many of the world's largest technology companies use Python in different parts of their systems. Let's look at a few examples. Google. Google has supported Python for many years. Engineers use Python for internal tools, automation, cloud services, and many other applications. Its simplicity allows developers to build solutions quickly. Instagram is one of the largest social media platforms in the world. Millions of users upload photos every single day. Python, particularly the Django framework, has played an important role in Instagram's backend infrastructure. Imagine the amount of information Instagram handles every second: photos, videos, messages, comments, likes, notifications. Managing all of that requires powerful software. Netflix. Every time Netflix recommends a movie, suggests a TV show, or analyzes viewing patterns, Python is commonly used in many data-related workflows. Recommendation systems depend heavily on data analysis. Python excels in that area. Spotify. Have you ever wondered how Spotify recommends songs you might like? Behind those recommendations are data analysis and machine learning techniques. Python helps developers process huge amounts of listening data to improve user recommendations. Dropbox. Dropbox stores millions of files for users around the world. Python has been an important part of Dropbox's development because it allows rapid software development and maintenance. NASA space missions generate enormous amounts of scientific data. Python has been used in various engineering, research, and automation tasks because of its flexibility and rich ecosystem of scientific libraries. Now here's something important. These companies don't choose Python simply because it's popular. They choose it because it solves real problems. It helps teams develop software faster. It reduces development time. It improves readability. It makes collaboration easier. That should motivate you, because when you're learning Python, you're learning the same language used by some of the world's biggest technology companies. Who knows? One day, you might even contribute to software used by millions of people around the world. SLIDE 15, conclusion, and WHAT's NEXT. Well, everyone, congratulations. You've officially completed the very first section of this Python programming course. And believe me, this first step is one of the most important ones. Many people say, "I'll learn programming someday," but they never actually begin. Today, you began, and that's something to be proud of. Let's look back once more. Today we learned what programming actually means, why programming languages exist, what Python is, who created Python, why it's called Python, why Python became so popular, where Python is used, career opportunities after learning Python. That's a lot of knowledge for a single session. But remember, knowledge alone isn't enough. Programming is a practical skill. Imagine trying to learn swimming by only reading books. Would that work? No. Eventually, you have to enter the water. Programming is exactly the same. Soon, you'll stop just listening. You'll start writing code yourself. You'll make mistakes. You'll get errors. Sometimes your program won't work, and that's completely normal. Every experienced programmer still encounters errors. The difference is they've learned not to fear them. Instead, they treat errors like clues. Each error teaches something new, so never feel discouraged. In our next section, we'll move beyond theory. We'll dive deeper into Python itself. You'll learn more about why Python became one of the world's favorite programming languages. We'll compare Python with other programming languages. We'll understand its design philosophy, its strengths, its advantages, and why companies continue choosing Python over many alternatives. Every lecture from now on builds on today's foundation. So if anything felt confusing, don't worry. We'll revisit many of these ideas again. Learning is all about repetition. Before we finish, I want to leave you with one final thought. Technology changes every single day. New programming languages appear. New tools are created. New frameworks become popular. But one thing never changes: the ability to think logically, the ability to solve problems, the ability to learn continuously. Those skills will stay valuable throughout your career. Python is simply the tool we'll use to develop those skills. So don't focus only on memorizing syntax. Focus on understanding concepts. Focus on thinking like a programmer. Because once you can think like a programmer, learning any programming language becomes much easier. Thank you so much for joining me in this first section. I hope you enjoyed today's session and learned something valuable. Take some time to revise your notes, review today's concepts, and if possible, try explaining today's lecture to a friend, because one of the best ways to learn something is to teach it. I'm excited to continue this journey with all of you, so get ready, because in the next section, we'll explore why Python in much greater depth and discover exactly what makes it one of the most loved programming languages in the world. Until then, take care, keep learning, keep practicing, and remember, every expert programmer was once a complete beginner. See you in the next lecture.
And that's it for this video. The slide deck we just went through along with all example code is available to download in the description. Grab it if you want to revise later or try the example yourself before you move on. This is a part of a full series covering the entire INT 108 Python programming syllabus from start to finish. So if you want to keep going, the rest of the series is linked in the description too. A quick tip before you go, the best way to actually hold on to what we just covered is to open your own editor and try it yourself, not just watch. I am Mohit Kumar Panigrahi. This is my summer project and I will see you in the next video. Thanks for watching.